Tina Slally. We be working all day long with a push of Spani. We ain't playing no games. Sabatavi, Ngani.
Good day, grade 11. We are still continuing with solving simple sets equation. Remember, we said on the previous video that the steps that you need to follow here, you isolate the set, then you square both sides, which is your step number 2. Then step number 3, then you solve for x. Then step number 4, then you check. So without wasting more time, we have this question. Remember, good people, you can pause the video and try to attempt this question on your own. So we're given solve for x, root 2x minus 1 minus root x minus 1 equals to 1. Remember, when I'm solving this equation, guys, this question, I have to follow these steps. Step number 1 says I must isolate the set. So I must isolate the set. But the tricky part here, we have 2 sets here. So it is very important that you follow these steps. So I'm going to isolate one of the sets here. Then I perform these steps. So to make my life easy, I'm going to transpose the one that is negative to that side to make it positive. So here I'm going to leave a root here, 2x minus 1. I'm going to isolate this side only, but if you want to isolate this one, it's up to you. And then equals to 1. Remember, on the right hand side we already have 1. Then if I transpose negative root x minus 1 to the other side, the sign here is going to change to become positive square root x minus 1. Yes, so we have step number 1, which is isolate the set. Now we need to perform step number 2, which is square both sides. So I'm going to square both sides. Whatever I do on my left side, I must also do it on my right hand side. The reason we square, because we want to get what is inside the root. So then I square again here. So this squared will cancel this root. So we are left with what here? We are left with 2x minus 1 equals to, remember this thing, guys, we will open 2 set of brackets because it duplicates. So I'm going to say it's 1 plus root x minus 1, then open another bracket, which is 1 plus root x minus 1. Hope that we are together. Yes, so we drop again what we have on the left hand side, which is 2x minus 1. Then we have to expand here. So I'm going to say 1 times 1, then I get 1. Then 1 times root x minus 1. Remember, anything multiplied by 1 remains the same. So if I say 1 times root x minus 1, so my answer is going to remain as root x minus 1, because anything multiplied by 1 remains the same. Then we are done with this one. Now we have to use root x minus 1. So if I say root x minus 1 times 1, again we get what? Root x minus 1. Yes, then I'm happy because I see the progress. So now we have positive times a positive. What do we get? It's positive. Then if I say root x times root x, remember, what do we have inside the root, good people? We have the same thing. It's x minus 1, and also here it's x minus 1. So it's more like if I'm saying to you, good people, that root x times root x, what do we get? We get x. Because if you can break this thing out using the rational exponent, it's going to be x to the power 1 over 2 times x to the power 1 over 2. Now can you see the bases will be the same? Then you're going to take one base and add the exponent. So here immediately you see that you have the same root. Then what you have inside is also the same. So here we are going to be left with what? With x minus 1. So maybe you're asking yourself why I put brackets here. Because some of the cases you will have a positive and a negative. So you have to mind the signs. So we're going to drop this one again. It's 2x minus 1. Remember, we did step number 2, which is square both sides. Now we're trying to do step number 3. which is solve for x. But the tricky part again, good people, we are still having the what? The set again. So I'm going to say, okay, no, anything that is the positive does not affect anything here. So I'm going to have 1 plus, remember this thing is the same as 2x plus 2x. Remember the coefficient here is what? It's 1. But whatever that we have inside the set is still the same. So root x minus 1 plus root x minus 1 is going to give me 2 root x minus 1. Hope we are together. Then a positive times a positive, we get a positive. Then 1 times x, we get x. Then 1 times negative 1, we get negative 1. Yes, so what will happen to positive 1 and a positive 1? They cancel out. Now I have 2x minus 1 equals to 2 root x minus 1 plus x. Hope you can see. Now we are still having the root. Remember we did step number 1. Now we're trying to do step number 3. So we are unable to solve for x now because we are still having the root. So now if I'm still having the root again, I have to repeat again step number 1. So I have to isolate the set again. So in order for me to make my life easy, I'm going to transpose this x to that side. So I'm going to have 2x minus 1 here. Then if I transpose the positive x to this side, the sign is going to change to become minus x. Right. And then on this side, I have 2x minus 1. Yes. So now 2x minus x will give me x minus 1 equals to 2 root x minus 1. So I have to perform, because I repeated step number 1, so I have to perform step number 2 again, then I go to step number 3. So the set now is isolated, so I have to square both sides. So whatever I do on my left side, I must also do it on my right hand side. So this, it duplicates. So I have x minus 1 and the x minus 1. Good. So here, guys, remember this squared will affect also these 2. The power here is 1. So in other words, we're going to apply here laws of exponents, which is law number 3. So which means 2 times 1 we get 2, then 2 to the power 2 we get what? 4. Remember, this squared will cancel this root. Now I'm going to open the brackets because this is a binomial. So inside I have x minus 1. Yes, I hope this is clear. So I have to expand this one. So I'm going to say x times x, I'm getting x squared. Then I say x times minus 1, we get negative x. Then we're done with this x. So I'm going to say negative 1 times x, we get negative x. So negative 1 times negative 1, we get positive 1. Wow, this is beautiful. This is beautiful. So this side we have 4 times x, we have 4x. Then 4 times negative 1, we get negative 4. Yes, now it's easy. So we don't have, we are no longer having the set now. We have to apply step number 3, which is solve for x. I have to put this equation into a standard form. So if I simplify what I have on my left hand side, it's going to be x squared, then negative x minus x will give me minus 2x plus 1 equals to 4x minus 1. Now it's easy, grade 11. Now you can see what we must do now. Yes, I can see that you are all saying that we must transpose whatever that we have on the right hand side to the left hand side. So I'm going to have x squared here minus 2x plus 1. Remember, if I transpose positive x to that side, the sign is going to change to become minus 4x. You must be careful with the signs. So if I transpose negative 4 to that side, the sign is going to change to become positive 4x. What do we have on the right hand side? We have 0. Immediately you forget is this equal sign. You are no longer talking about an equation, you are talking about an expression. So you already changed the answer. So we drop x squared here again. Then negative 2x minus 4x will give us what? Negative 6x. Yes. Then 1 plus 4 will give me 5. Equals to what? To 0. Now it's a matter of what? Of factorizing. So I'm going to open 2 set of brackets here. because the power degree here is 2, so which means I need 2 solutions, so equals to 0. So the factors of x squared is simple, it's x and an x. But the factors of 5 is a prime number, so it's only 5 times 1. So that's the only factors that we have is 5 times 1. Since our c, the constant, is positive, the signs inside the brackets must be the same, similar to the sign which is in the middle term. So we have negative here, so I'm going to put minus and a minus. Yes, you know the 0 rule or the product rule. So these brackets, x minus 1 must be equal to 0, or x minus 5 must be equal to 0. Then we transpose that, therefore my x is going to be 1, or x is equals to 5. Yes, this is beautiful. Maths is beautiful. So now we have to conclude, because we're not done, because we did step number 3. Now we have to perform step number 4. We check the solutions by substituting the both answers into the original equation to see which is the solution that we want. So I'm going to write here check. So we want to find which solution that we must take here. I will write here on this side if x is equals to 1. And then on this side I will write if x is equals to 5. Then I will cut it here. Remember, we have to go back to the original equation. Remember, the original equation was this one. So wherever I see x, I must substitute the value that we have here. So remember, can you see now we have a root here, 2. So in place of x, I have to substitute this one, minus 1, minus again a root here. We have 1 in place of x, minus 1 equals to 1. Remember, this is the left hand side, this is the right hand side. If the left hand side is not equal to the right hand side, this is not a solution. So you have your calculator, you know that 2 times 1 will give me 2, minus 1 will give me 1, root 1 will give me 1, and then 1 minus 1 here, we have 0, and then root 0 will give me 0 equals to 1. So 1 minus 0, we get 1. So can you see that the left hand side here is equal to the what? To the right hand side. So which means this is the solution. So we have to go to 5 and use 5 and check 5 if it is a solution or not by applying the same technique. So I have 2, then in place of x we substitute by 5 minus 1 minus, then remember we have 5 in place of x, minus 1 equals to 1. Yes, so you can press your magic machine. So 2 times 5 will give me 10, 10 minus 1 will give me a 9, minus, then if I say 5 minus 1 will give me 4 equals to 1. So can you see that square root of 9 will give me 3, minus square root of 4 will give me 2, so equals to 1. So 3 minus 2 will give me 1 equal to 1. So which means here the left hand side also is equal to the what? To the right hand side. So now we can make the conclusion simple that x is equals to 1 or x is equals to 5. So both answers are correct. So we have 2 solutions in this case. So it is very important to check your solutions if are valid or not by substituting into the original equation. So let's see what do we have for the next questions. We have this question, guys. Solve for x again. This is the last video that we have when we are solving for the set. So we have they say solve for x, it's x squared minus 5 equals to root x squared plus 1. Okay, so this is tricky, at the same time it's very interesting. Maybe you are asking yourself, what must we do here? Because if I introduce step number 1, because when you are solving for set, step number 1 said isolate the set, so we can see that the set here is already isolated. So now we have to square both sides. But if I square both sides, I'm going to get the complicated numbers, because we have the power degree here, which is 2. So if I expand, I will get x to the power 4, which is not something that we want. So I have to introduce something new here, which is the K method. Can you agree with me that if I have 5, I can present 5 as 4 plus 1. I can represent this 5 again as 6 minus 1. Are we together? I can represent this 5 again by 9 minus 4, depending on what I want. So this thing, I cannot change this one, but I want to destroy the root so that I can solve for x. So since I have here x squared minus 5, I'm going to drop this thing down. Can you see, gentlemen, ladies and gentlemen, that we have x squared here, and also we have x squared under the square root. I'm going to drop my x squared again. But we have positive 1, but on this side we have negative 5. So if I put a negative 5 here, what number must we add in order for us to get again positive 1? What is what number we must add here? Yes, it's positive what? 6. Because if I say negative 5 plus 6, I get positive 1 again. So can you see now this thing is the same with this one? So I can see that I have the repeated numbers. I will tell the marker, no, say, let x to the power 2 minus 5 be any variable holder. Maybe you can say b m if you want, or you can say bk. So in place of x squared minus 5, now I see m. So I'm going to put m here to make it simple. So now I have m plus 6. Now it's easy. I can perform the steps that we have. Now I can square both sides. So if I square both sides, whatever I do on my left hand side, I must also do it on my right hand side. So m is going to give me m squared. So this squared is going to cancel this root. Now we have m plus 6. Now it's a matter of factorizing. So now we have to solve for m. Remember, good people, on this side we have m squared. Then if I transpose this positive m to that side, the sign is going to change to become minus m. If I transpose 6 to that side, the sign is going to change again to be minus 6, equal to what? To 0. Wow, this is beautiful. Now I can see that you are smiling because you see that it's easy to go now. So we can open the two set of brackets, equals to what? To 0. The factors of m squared is simple. It's m and the m, because m times m will give me m squared. But the factors of 6 is the composite number. So we have 6 times 1, we have 3 times 2. But we want the factors, when we add or subtract, we get the middle term. So our middle term here is negative 1. So we can see that if I say 6 minus 1, we get 5. If I say 6 plus 1, we get 7. So this is not the factors that we want. But if I say 3 minus 2, we get 1. So I'm going to use these factors. So I have 3 and a 2. But our c, good people, is negative, which means the signs inside the brackets must not be the same. But the sign, since our signs are not going to be the same, the big factor is going to take the sign of the what? Of the middle term. So in this case, 3 is going to be your big factor. So it's going to be negative, and this one is going to be positive. So by zero rule here, our product rule, we know that m plus 2 must be equal to 0. Or m minus 3 must be equal to 0. So we can conclude that m is equal to minus 2, or m is equal to 3. This is beautiful. But ladies and gents, we're not solving for m, we're solving for what? For x. So we need to bring back x squared minus 5. So in place of what? Of m. So I'm going to communicate with the marker that but x squared minus 5 is equals to what? To m. So now in place of m, we are no longer putting m. We're going to bring back x squared minus 5 equals to negative 2, or x squared minus 5 equals to positive 3. That's it. Okay, So what must we do now? I have to transpose this 5 to that side. So if I say x is equal to -2 plus 5. Now we can see, ladies and gents, that -2 plus 5 will give me +3. What must we do now? Because this thing, guys, is not the same as the root. So if I introduce the square root both sides here. So I will have this one will cancel out. So now we have x is equal to root 3. So if I go to that side, so this is x is equals to 3 plus 5. So then this is x squared is equals to 3 plus 5 is going to give me 8. So can you see now we're not looking for x squared, we're looking for x. So what must we do here? So we're going to introduce the square root here. Again, what I did here, I will also do it on this side. So this is going to cancel this. Now we have x is equals to root 8. So which step we need to perform again here? We need to check because we managed to solve for x. So if I take this one and substitute here, then I will tell the marker that check what? Check if x is equals to root 3 or x is equals to root 8. So if we substitute, good people, here, it's going to be easy because we are going to use our original equation. We have to check if the left hand side is equal to the right hand side. Remember, this thing will never be equals to the negative number. Remember your principle that the square root or the set will never be equals to a negative number. That's what we said on the previous video. So if you didn't watch my previous video, so I highly encourage or recommend to watch the first video. So here I'm going to use the original equation. Let's cut this one here. So wherever I see the x on the original equation, I'm going to substitute this value. So I have root 3, then I have squared outside, minus 5 equals to, this is beautiful, I love this maths. So we have root 3 squared plus 1. You have your magic machine, good people. You can just open your brackets and substitute root, then you put squared, then you have minus 5. Now this is easy. We can see this is minus 2 already. It tells me something. Then if I go to the left hand side, to the right hand side, I have square root of 3 squared plus 1. We get what here? 2. Now can you see that the left is not equal to the right hand side? So now we can cancel this. Therefore the left hand side is not equal to the what? To the right hand side. Okay, so we have to check. So this is not a solution, so we have to check 8 now. By using the original equation again, I will have root 8 then squared minus 5 equals to, inside I have root 8, I'm running out of the marker, so plus 1 here. Hope that you can see. So if you press your calculator, this one will cancel out. Now I will have 8 minus 5, which give me 3. Then if we go, we check the left hand side, the right hand side, I have root and the root 8, then all squared plus 1. What do we get? We get 3 again. Now can you see this is the solution? So therefore here the left hand side is equals to the right hand side. Now we can make the conclusion here, good people, that therefore x is equals to root 8 only. Don't forget that only. So that's your solution. So well, let's go to the next question before we do the last question. So the next question we have 5 times cube root x to the power 4 equals to 405. So we're still solving for x. Remember, we're still having the set, so we need to follow the steps that we used when we are solving for set. So you can pause the video and try to attempt this question on your own. So can you see that, guys? We have the single number here and also the single number here. It's more like if we are having 7x equals to 14. What you you will do here when you are solving for x, the first thing that you need to do, you will get rid of this coefficient. So that's what we will do here, because I can see that this is 5 times cube root x to the power 4 equals to 400. So the first thing that I need to do here, I need to get rid of this 5 by dividing, because between these terms I have the multiplication. So the opposite of multiplication is division. So I have to divide both sides by what? By 5. So this 5 is going to cancel this one. Now I have cube root here, x to the power 4 equals to, then if I say 400 divided by 5, 405 divided by 5, what do we get here? We get 81, right? So now it's easy, guys, to attempt this question. Remember, you can take out Mandela out of the prison. So if we take Nelson Mandela out of the prison, it's going to be x. Remember, I will write this thing in the rational exponent. So it's going to be 4 over 3 equals to 81, right? So 81, good people, is not, there are many ways to do this. I know that there are many ways you can attempt it with in different way. So here, guys, we know that 81 is the same. Let's drop this one, x to the power 4 over 3. We know that 81 is not a prime number. You can press 81 on your calculator, then you press shift, then you press you press 81, you press equal sign, then you press shift, then you use this partition fact. Can you see that 81 is 3 to the power 4? So this can be changed to be 3 to the power 4. So now it's easy to us to move. I have x to 4 over 3 equals to 3 to the power 4. What must we do now? We have to do the reciprocal for this. So I'm going to open the brackets here. I'm going to say times by 3 over 4. Whatever that we do on the left hand side, we must also do it on the right hand side. So this is going to be times by 3 over 4. Right? So now we are left with what? This is going to cancel this. This is going to cancel this. Now we have x on this side. So this one is going to cancel this one. Right? So if this 4 cancel this 4, because this thing is the same as if you apply law number 3, your laws of exponents, is 4 times 3 over 4, which is 12 over 4. Then 12 divided by 4, we get 3. So I have 3 to the power 3. Then 3 to the power 3 is the same as 27. So that's the value of x. So now we have to check. So if I check, good people, it's going to be easy. And then I will say check. Why do I check? Because I have the set here. Check if x is equals to 27. Then I go straight to the original equation. Wherever I see x, I will substitute 27. All right. So I have 5 cube root here. Then I have 27 to the power 4 equals to 400. So I must press this one on my calculator and see if I get 405. If we don't get 405, so which means there's no solution for this equation. So I have 5, good people. And then I have a cube root 3 cube root 27 to the power 4. So this is also 405. So therefore we can conclude that x is equals to 27. Right. I hope that we are on the same page. So let's go and do the last questions that we have here. Remember, you can pause the video and try to attempt these questions on your own. We're given the last question. We're doing the last question here, ladies and gents. So we have x minus 4 root x plus 3. There are many ways to do this one, because inside the root, inside the side, we have only x. So I will do it in different ways. You will choose the one that you want. You will choose the one that you want, because But the first method that I'm going to use here is the one that we're already using. The steps that we follow when you are solving the set, which is you isolate, then you square, then you solve for x, then you check. So let's see what we must do here. Step number 1 says isolate the set. So this is what we have, the set here. So I have to isolate the set. So can you see that this is negative? So I hate negative. I'm going to transpose this minus 4 root x to that side so that the sign is going to change. So I will have here x plus 3. This 3 equals to 4 root x. What must I do next here? I must square both sides. Whatever I do on my right hand side, I must also do it on my left hand side. Remember this, it duplicates, good people. So now I'll open two set of brackets. This is cheap. You can get it from the spaza shop. So remember these two guys will also affect this 4 to the power 1. So which is 2 times 1, we get 4 to the power 2. 4 to the power 2 will give me what? 16. Now this 2 will also affect this root. So this 2 is going to cancel this root. Now we have x here. So if I expand this, I'm going to say x times x. It's x squared. X times 3, we get 3x. And then positive 3 times x, we get positive 3x again. Then 3 times 3, we get positive 9 equals to 16x. So now we have to collect the like terms and try to simplify what we have on the left hand side. So I have x squared here plus, remember, 3x plus 3x will give us what? 6x plus 9 equals to 16. Remember now we're already performing step number 3. So we have to put this equation into a standard form. So I'm going to transpose 16 to that side. I will have x squared plus 6x plus 9 minus 16x equals to 0. So we drop again x squared, but positive 6 minus 16 will give us negative 10x plus 9. This is cheap. So then it's a matter of what now? Of factorizing, because we managed to get this standard. So we now need to solve for x. So I'm going to open two set of brackets here. So I have x, the factors of x squared is x, and the x, but the factors of 9, because 9, guys, it's not a prime number, it's a composite number. It's 9 times 1 and a 3 times 3. But we need the factors. When we add or subtract, we get 10. So in this case, it's 9 and 1. So I'm going to use 9 and a 1. But our c is positive, so the signs inside the brackets must be the same. So I'm going to have, I'm going to use this sign. It's going to be minus and a minus. Okay. So therefore, my x will be equals to 1, or x is equals to 9. What must we do now? We need to check. So check, I'm going to say check if x is equals to 1, then if x here is equal to 9. Right. So where do we check, guys? We use the original equation. So I will go back straight to my original equation. Wherever I see x, I'm going to substitute the value that we got here. So in place of x, I will put 1 minus 4. I hope that you can see this equation. This is our equation. Root in place of x, again we put 1 plus 3 equals to 0. Let's cut it here. So remember the right hand side is 0. If we punch this one on a calculator, we have 4 minus, because root 1 will give me 1. Negative 4 times 1, we get negative 4 plus 3 equals to 0. But if you punch this one on your calculator, because 1 minus 4 will give us negative 3, negative 3 plus 3 will give us 0. Now we can see that 0 is equal to 0, that the left hand side will be equal to the what? To the right hand side. So in this case, so this is the solution. So now we have to check for 9. So we're going to substitute just like what we did for 1. So we have 9 minus 4 root 9 plus 3 equals to 0. To make your life easy, you can just punch your calculator as it is. We have 9 minus 4 root 9 plus 3. So we get again 0, which is equals to 0. So now we can say that x is equals to 1 or x is equals to 9. So this is your solution. So I'm going to do this question again with different method. So in different methods so that you can see, but I'm not going to complete it. So we have x here minus 4 root x plus 3 equals to 0, right? Guys, we have this x minus 4. We know that root is the same, let's put x here, is the same as x to 1 over 2, because we know that the radical number here is 2. So I can change this one to be x to 1 over 2 plus 3 equals to 0. So we know that if I break this one out, this one I can try to factorize as it is, like that. So, but I will make it to be easy for you, gentlemen, so that we have here 1 over 2. I can break this one to be 1 over 2 times x to 1 over 2 minus 4 x to 1 over 2 plus 3. Now, can you see this? The bases are the same. We take one base and add the exponent. So half plus half is still going to give us this one. Now we introduce the k method. Say let x1 over 2 be any variable holder. You can say be k or m. So in place of this one, I have m here times m minus 4. Then I have m plus 3 equals to 0. Now, if I say m times m, what do we get? It's m squared minus 4m plus 3 equals to 0. So it's a matter of factorizing now, good people. Now you will just factorize here. So the factors of m squared is m, and the factors of 3 is a prime number. It's only 3 and a 1. But the c is positive, so the signs inside the brackets must be the what? Must be the same. So I'm going to take this sign, the Mikla sign, which is negative and a negative. So therefore your m is going to be positive 1, or m is going to be positive 3. But you were not solving for m, so I'm going to say but m is equals to x to 1 over 2. So in place of m now we bring back x. So we have x to 1 over 2 is equals to 1. Or we have x to 1 over 2 is equals to 3. This is the even number. This rational number is divided by an even number. So you know the rules. So we have x 1 over 2. Then we change this one by, we do the reciprocal. So I'm going to flip that. We multiply by 2 over 1. Whatever that I do on my left hand side, I must also do it on my right hand side. So I multiply by 2 over 1. So this 2 will cancel this 2, this 1 will cancel this 1. Now we have x here. So 2 over 1 is the same as 2. Then we have 1 to the power 2, which is the same as 1. Now we go to this one. We have x to the power 1 over 2 equals to 3. Then we must reciprocate this rational exponent by multiplying by 2 over 1 both sides, by 2 over 1. So remember guys, you know that if I have 2, we have 1 here. So this one will cancel this one, this 2 will cancel this 2. Now we are left with x. So 2 divided by 1 is still going to give us 2. Then it's the same as if I have 3 to the power 2. Then 3 to the power 2 will give me 9. So which means it's the same solution that we get here when we're using the first method where we isolate the set. So we're still going to get 9 and 1. So this is the solutions that we have here. So which is x is equal to 1 and x is equal to 9. Then you do step number 4, which is you go and check for your solution. But you only use this method whenever you have only x under the root, under the set. But if I have x plus 1, I was not going to use this method of changing the exponent, of changing the root. So you only change the root whenever you have only x under the what? The root. So this was our last question, ladies and gentlemen. I hope you enjoyed the lesson. So don't forget, if you didn't, you are not part of the family, don't forget to subscribe and hit the button thumbs up. and tell us how do you feel about our lessons. I hope to see you next time. Don't forget to share the video and tell your friends about this YouTube channel. Thank you for watching. See you on the next video.